Hello everyone, today we are going to discuss a very interesting topic of physics, that is electromagnetism. So what is electromagnetism? Obviously you get a concept of from the word what is electromagnetism. So the word electro, it's indicate the electric, and the magnetism obviously it's indicate the magnet. So there is a relation between electric and magnet we will discuss in this chapter in electromagnetism. So there is a relation between electric and magnet, so that relation is called the electromagnetism. Okay, so actually in 1820 during the experiment, a scientist whose name is Oersted, he found something. What he found that whenever current is passing through the conductor, then there is some deflection happen in the magnetic needle. So we know that there is a magnetic needle which is found which you can get in the market. So there is a magnetic needle, or you can say that a needle compass. So what he found that whenever current is passing through the conductor, then there is some deflection happen in the magnetic needle. So magnetic needle only deflect whenever there is a around a magnetic field. Suppose that if you take a magnet, suppose this one is a magnet. Suppose this one is a magnet, and if you place a magnetic needle or compass over here, so there will be some deflection happen on the magnetic needle. So that deflection indicate that there is some magnetic field around the magnet. Okay, and if there is no magnet the present, then the magnetic needle always just pointed out the north pole and south pole generally. But whenever you place in the magnetic field, suppose this one is a magnet, and if you place a magnetic needle just around just near to the magnet, so there will be some deflection happen. If you place over here, there will be some deflection. It will be not at the wrist, but if you remove the magnet, so it will be indicate at the north and south. So we get one concept that deflection of the deflection will be only happen when the needle is placed around or near to the magnet. But he found a unique things. Whenever current is passing through the conductor, whenever suppose this one is a conductor, and when the current is passing through this conductor, and if you place a magnetic needle, there is some deflection he noticed. So what he found that whenever there is a current passing through the conductor, then a magnetic field produced around the conductor. Okay, whenever current is passing through the conductor, then a magnetic field around, then there is a magnetic field around the conductor. Okay, so from here he get the concept of relation between electric and magnetism. Okay, so now if we do the experiment related to that, so we conclude the something. Okay, so now take a cardboard and just make a hole and pass a electrical wire, and then you just place some iron filing over the sheet, and if you will pass the current through the wire, so you will see that. And if you start now a small just do a small push over the sheet, so you will observe that the iron filing will be arranged in a circular way. Suppose this one is a cardboard, and if you just make an hole here, and a conductor is passing through the hole. Okay, and you place some iron filing over the sheets, and whenever the current passing through the wire, if you will just tap over the sheet, what you will observe, all the iron filing will be arranged in a circular way. Okay, so what will be the direction of magnetic field? So remember that the direction of the magnetic field, if you place the magnetic compass over the sheet, so what is the direction of the north pole? That will be the direction of magnetic field. You remember this point? The direction of north pole, will be the direction of magnetic field. Okay, is it clear? So suppose if you current passing through this wire and if you just tap the cardboard, all iron filing will be arranged in a some way. It will be look like a circle, and if you place at any position this magnetic compass or magnetic needle, so you will see whatever the direction of the north pole, means suppose if you, this one is a cardboard, and if you place a needle here, if you place, and the circular wire is passing through this hole and current is passing through the conductor, and if you place magnetic needle here, suppose this black portion indicate the direction of the north pole. If the direction of the north pole will be here, suppose the direction of the north pole will be here, so this one will be the direction of magnetic field. Okay, if suppose again if you place the magnetic needle here, again if you place magnetic needle here, and the north pole will be indicated in this direction. If you place magnetic needle here, the north pole will be directed pointed to this direction, so this one will be the direction of magnetic field. Is it clear? You remember that the direction of the north pole will be the direction of magnetic field. So now from this experiment what we conclude, so for magnetic field and magnetic lines due to the current in a straight wire, so what you will be observed from here, so the magnetic field lines form the concentric circle around the wire. So obviously what you will observe, all the iron filing will make a concentric circle. So the magnetic field lines form the concentric circle around the, what is the magnetic field lines? So whenever you place the magnetic needle here, so it will be given some direction. So if you place at all the position, you will get a line. Okay, or you can say that this is the imaginary line. Okay, magnetic field line, that will be the imaginary line. Mean whenever you tap the cardboard, you will feel that all the iron filing will be arranged in a line. So that line, if you draw the imaginary line, that line is called the magnetic field line. So magnetic field line form the concentric circle around the wire and the center line on the wire. So this wire will be look like a center. First point is clear. Now the second point, if you change the direction of the current, no arrangement will be changed. No arrangement, the filing will be no change. But remember, the deflection of the north pole will be changed. Second point is clear. If you change the direction of the current, the deflection of the needle get reversed. Suppose this one is a wire, first you current passing through this direction, and the north pole will be directed on this direction. The north pole will be deflected in this direction, and sudden if you change the direction of the current, now you change the direction of the current from here. So now the north pole, for initially it was when the current passing through the here, the north pole deflected in this way. Now if you change the direction, so north pole will be deflected in this way. I hope the point is clear. Second one, if you change the direction of the current, the deflection of the needle will get reversed, or direction of the needle will be also changed. Is it clear? Second point is clear. Now if you increase the strength of the magnetic field, if you increase the strength of the conductor, if you increase the strength of current, the one line is missed here, one word is missing here, strength of current, then magnetic field line become denser. What is the meaning of this line? Just give me a minute. Suppose if you increase the strength of the current, suppose initially you just passing the 5 ampere, now you increase the potential difference, or the strength of the current will be increased, then the magnetic field line become denser. What is the meaning? Suppose in initial case the magnetic field lines will be make of 5 layers. Now if you increase the strength of the current, so magnetic field lines will be 10 layers, 11 layers, 12 layers, so it will be denser. Okay, so it indicate the if you increase the strength of the current, then the magnetic field line will become denser. So these are the three important observations we get from a straight wire current carrying conductor. If a straight wire carrying current, we get the 3 points. Number one, the iron filing make a concentric circle with the center as a wire as a center. The second point, we conclude from the experiment, what is that if you change the direction of the current, then the arrangement of the iron filing will be not change. What will be changed? The deflection of the needle will be changed. And the third point, we conclude from the experiment, if you increase the strength of the current, the magnetic field line become denser. Okay, I hope the questions will become from here, you are able to solve. Now the direction of the magnetic field we can find through the needle, but how to find the direction of magnetic field? Okay, so the direction of the magnetic field we can find through the right hand thumbs rule. What is right hand thumbs rule? Let's see. Direction of north pole of the needle will be the direction of magnetic field. You just keep in your mind, this is a very important point. Okay, now see, what is right hand thumb? We can find the direction of the magnetic field through the magnetic needle, but theoretically how we can find the magnetic field lines or magnetic field, the direction of the magnetic field? So what is right hand thumbs rule? Right hand thumbs rule, you say that hold right hand first, right, then I will explain. Okay, if you hold the current carrying conductor in your right hand such that thumb points in the direction of flow of current, then the finger encircle the wire is the direction of magnetic field. What is the meaning? So now theoretically how we can find what is the direction of magnetic fields? So remember that if you hold the current carrying conductor in your right hand such that the thumbs point in the direction of the flow of current, then the fingers encircle the wire is the direction of magnetic field. Okay, so simply we can find the direction of the magnetic field through the magnetic compass. Now theoretically how we can find? So right hand thumb rules, suppose that this one is a current carrying conductor. Okay, and if I hold this one in the right hand, so if this thumb indicate the direction of the conductor, then what will be the direction of magnetic lines of force? What will be the direction of the magnetic field? So the all fingers which encircle the wire means the direction of the magnetic lines of force will be this. Matlab means if you place the magnetic needle here, so north pole will be direct this direction, north pole will be indicate this direction, point this direction. If you place the needle here, suppose okay, this is the direction of the conductor, this is the direction of the current, and if you hold this wire on the right hand, thumbs will be indicate the direction of the wire, then the finger encircle the wire. These indicate the direction of magnetic field. Is it clear? The finger encircle will be indicate the direction of magnetic field. Is it clear? Is it clear? So if you hold the current carrying conductor in your right hand such that thumbs point the direction of the flow of current, then the fingers encircle indicate the direction of magnetic field. This one is the right. Let's see what happens if the current is passing through a circular wire or a loop. Okay, so let's see what happens if the current is passing through the circular wire. So obviously we already learned that whenever current passing through the straight wire, so then there will be electrical field is generate around the wire. So now let's see what happens when the current is passing through a circular wire. Okay, so magnetic field due to the current in a loop. Okay, at the P and Q, suppose this one is a loop or wire, circular wire. Okay, and from this wire the current is, this wire is connected to a battery, and now current is passing from this direction to this direction. Okay, so now obviously current is passing through here, and if you place some iron filing over the sheet, so you will get that, and if you start, when the current passing through here, if you start tapping here, so you will get that there will be a concentric circle will be formed. So now what we conclude from this, so you just see that at the P and Q the magnetic field lines are nearly circular. Means at the point P and Q means the point where the current is passing. So at this point the magnetic field will be look like a nearly circle. Okay, at the point P and Q, at the point P and Q, at the point P and Q, the iron filing will be look like a circle. So at the point P and Q, so obviously whenever this iron file will be indicate the magnetic lines of a force. Okay, and the direction we can find through either the compass or right hand thumb rules. Okay, so what will be the direction of magnetic lines of force? So at the point P and Q, what will be happen? At the point P and Q, magnetic field lines are nearly circular. Now what is the second point? What we can observe from here? Within the space P and Q, the magnetic field lines are in same direction. So if you will see the magnetic lines of force of this here, so you will see that the magnetic lines of force are in the same direction. Okay, that will be nearly to the same direction. So within the space P and Q, the magnetic field lines are in same direction, and near the center the magnetic fields are nearly parallel to each other. Means at this near the center, means these are the centers of the concentric circle. So at this position, at this point, you will see that the magnetic lines of force, they are very nearly to look like a parallel. Okay, this point is clear. Number one, at the P and Q, magnetic field lines will be look like a very circle, very similar to circle. The second point, within the space P and Q, within this space P and Q, the magnetic field lines will be in the same direction. The third point, near the center, magnetic field lines are nearly parallel to each other. Now what we can conclude, at the center the magnetic field lines are along the axis of the loop, and normal to the plane. Okay, means what is the meaning? Means this these magnetic lines of force, if you will see that, if you will extend that, you will see that that will be perpendicular to this plane. Now the fourth point, first, second, third, fourth, fifth point, this point is a very important point. The magnetic lines of force, the magnetic lines become denser, means the strength of magnetic field will be more or denser. How? If we increase the strength of if we increase the strength of current. The point is clear. Means if you increase the strength of the strength of the current, then the magnetic lines of force will be more denser. More denser means the magnetic field will be strong. The strength of the magnetic field will be more strong. Okay, and how it can be? We can understand the magnetic field be strong. So this circle will be more thick. The iron filing will be more thick, and there will be number of circle will be formed. Okay, and how we can increase the strength of magnetic field? With the number of turn increase. Means suppose if there is a 1 ton, if I take the more than 2 ton, 3 ton, 4 ton, 5 ton, if we increase the number of turns, then the magnetic lines become denser. I hope this point is clear. Now let's see what is the polarity of conductor. Okay, so we know that whenever current is passing through the conductor, then there will be electrical field will be generated or produced around the conductor. So now if it will be behave as a conductor, then what is the polarity? Means which one will be indicate the north pole and which one will be indicate the south pole. So remember that whenever current is passing in anti-clockwise with a reference to your point, suppose I am standing here and current is passing in this way. Suppose current is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is generally written in the clock. So if current is passing through this way, in this way, in this way, in this way, in this way. Suppose this one is a wire and the current is passing in this way. That may be look from your side will be anti-clockwise. So remember, if the current is passing in this way, if current is passing in this way, so the phase which will be on your side, that will be considered as a north pole. And if the current with respect to your point, if it will be passing in the clockwise, what is the meaning of clockwise? Suppose current is passing it through like this way. This one is a direction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if the current is passing in this way with respect to your point, then this will be considered as a clockwise. I hope this point is clear. When the loop of the wire will be considered as a north pole and which one will be behave as a south pole. Okay, when the current is passing anti-clockwise in indicate north pole, and when the current is passing through clockwise, so so the rest part will be south pole, behave as a south pole. I hope this point is clear. Magnetic field due to current carrying circular wire or solenoid. Magnetic field carrying cylindrical wire, cylindrical conductor or solenoid. Okay, what is solenoid? What is solenoid? Suppose if you take any wire and just wound around any cylindrical piece. Suppose this one is a cylindrical piece and I take a piece of a wire here. Okay, if you turn or if you just make in this way, just wrap this wire in this plastic piece, cylindrical piece. So now if you will see that it will be, if you turn in this way means properly, not in this way, so this will be considered or this will be called a solenoid. Okay, and remember the one more point, its diameter will be always less than the length of the conductor or length of this piece. Okay, so this one will be considered as a solenoid. Okay, so generally what is the solenoid? So solenoid is a just a wound of wire or conductor. Okay, it will be look like a spring. Okay, it will be look like a spring. This one is a solenoid. So now we discuss magnetic field due to the current carrying conductor, cylindrical conductor or solenoid. So number one, you remember that the magnetic field will be around straight or parallel to axis of solenoid. What is the meaning? Means obviously whenever current passing through this solenoid, there will be magnetic field will be developed around this solenoid. So if you place the iron filing over there, so there will be they make a line and all. So inside this solenoid, that magnetic lines of force or magnetic field line will be straight or parallel to the axis of solenoid, means that will be moving in this way. All the iron firing will be straight. This point is clear. So the magnetic field will be around straight line. Magnetic field will be almost straight line or parallel to the axis of solenoid. First point is clear. The second point, you remember that the magnetic field will be more denser if you increase the strength of current. The magnetic field line will be more denser. If the magnetic field line will be more denser, it means that there will be a strong magnetic field. Okay, less denser means they are less in strength. And if the magnetic field line means that if the iron firing will be more denser, it indicates that they develop a very strong magnetic field. So now the question will come in the exam, how the magnetic field line or the magnetic field can be increased. So you just remember this point. If you increase the strength of the current, means the strength of the current, if you will be increased, the magnetic field will be more strong. So if you the magnetic field line will be more denser if you increase the strength of the current. Number 2, sorry, this one is the number 1. Number 2, if you increase the number of turns of the wire, mean suppose initially you just make a 5 turns, now you take the 10 turns or 50 turns. So if you increase the number of turns, then the magnetic field will be more strong. Okay, so the magnetic field will be more denser by increasing the strength of the current if you increase the number of turns of the wire. And number 3, if you place a soft iron inside the solenoid, then magnetic field line will be more denser. I hope these 4 points are clear. So remember that from this points we learn the 4 points. Means obviously whenever first we discuss what is the solenoid and how to increase the density of magnetic field line. So if you increase the number of turns, if you increase, just remember with the sequence, if we the magnetic field line will be more denser if you increase the strength of the current. If you increase the strength of the current, then the magnetic field line will be increased. Number 2, if you increase the number of turns, then the magnetic field line will be also increased. And number 3, if you place any soft iron inside the solenoid, then it will be more strong, it will be behave as a more strong magnet, so the magnetic field line will be more denser. Now let's see what is the similarities between the bar magnet and the solenoid. Okay, I hope this point is clear. So let's see what is the similarities between bar magnet and solenoid. Avoid my spelling in English. Okay, so remember that bar magnet attract magnetic substance. Solenoid also attract magnetic substance. Okay, when? Until the current is passed. Okay, until current pass. Okay, if you stop the passing current, its magnetic property will be also stop. Okay, so now talking about the similarities. So bar magnet is also attract the magnetic substance like iron. So whenever current passing through the solenoid, this will be also attract the magnetic substance. The second one, you remember that bar magnet is also its property that it always indicate the north pole and south pole. So when you place solenoid freely, it will be also indicate south pole and north pole. Okay, how we indicate south pole and north pole? I already told you that whenever the current is passing anti-clockwise, the phase which is in your side, that will be indicate the north pole. Anti-clockwise. Okay, so whenever you just freely place the solenoid in a space freely, it will be also indicate the south pole and north pole. These are the two similarities between the bar magnet and solenoid. Bar magnet is also attract the magnetic substance, and solenoid is also attract all the magnetic substance. Whenever you bar magnet is also always indicate the north pole and south pole, and whenever the current is passing through the solenoid, so and it will be leave freely, it will be also indicate the south pole and north pole. These are the similarities between the solenoid and bar magnet. Now we discuss what is the dissimilarities, means what is the difference between dissimilarities. So now you tell me what is the dissimilarities between the bar magnet and solenoid. So remember that the strength of solenoid can be increase or decrease. We already know by the increasing the strength of the current, by the increasing the number of turns, and if we place a soft iron inside the solenoid, so we can increase the strength of the current. Similarly, if we decrease the strength of the current, if we decrease the number of turns, then we can decrease the strength of magnetic power of solenoid. These are the dissimilar. But the bar magnet, we cannot change the strength of the magnet, but in bar magnet we cannot change the strength. The second point that the direction of north and south, means polarity, cannot change in bar magnet. Okay, the direction of north and south means polarity of the magnet we cannot change, but in solenoid what we can do, if the direction of the current will be changed, the deflection will be changed also. Okay, so these are the similarities, these are the dissimilarities. Similarities we already discussed that the strength of the current can be increased or decreased in the bar magnet, in solenoid, but in bar magnet we cannot change the strength of the current. The second one, like a bar magnet, solenoid is also attract the magnetic substance, bar magnet is also attract the magnetic substance like a iron and all. What are the dissimilarities? The strength of solenoid can be changed, but the strength of the bar magnet we cannot change, and the direction of north and south or the polarity of the bar magnet is fixed, but in solenoid we can change the direction of the current, so the deflection of the magnetic field will be changed. Okay, these are the dissimilarities of bar magnet and solenoid. So now we are going to cover the topics: electromagnet, shape of electromagnet, the way of increasing the magnetic field of an electromagnet, use of electromagnet and advantage of electromagnet over the permanent magnet, and comparison of electromagnet and permanent magnet. Let's see what is electromagnet. Obviously, with the help of electric current, if we make a magnet, that is a electromagnet. With the help of current, if we make a magnet, that will be a electromagnet, and this should be a temporary. What is electromagnet? It is a kind of temporary magnet. We already learned that if current passing through the conductor and if current passing through the solenoid, so it will be behave as a magnet. So that is a electromagnet. Okay, and remember that this one is a temporary magnet, not a permanent magnet. What is a permanent magnet? If a magnet is found in a naturally, that is a permanent magnet. And if you make a conductor as a current by passing through the current, it will be behave as a magnet, that will be electromagnet. So the shape of electromagnet, so this electromagnet we can convert in any shape, but generally the two shapes are widely used. That one is the I shape, or we can say that bar magnet, bar shape, and second one is the U shape. Okay, so these two shapes are generally come in widely use. Okay, now what is the way of increasing the magnetic field of an electromagnet? So we already learned in the solenoid how we increase the magnetic field. So same the magnetic field in the electromagnet we can increasing by generally two way. You remember that by increasing the current, by increasing the strength of current. And the second point, you remember that by increasing the number of turns in a solenoid, by increasing the number of turns, by increasing the number of turns. Okay, these are the two ways to increase the magnetic field. One directly questions come from here: how the strength of magnetic field of a solenoid can be increased. So you can answer that by increasing the number of turns of a wire, and the second one by the increasing the strength of the current. Now let's see what is the use of electromagnet. So basically there are different use of the electromagnet, but widely it is a use for lifting heavy iron scrap. Okay, number one means with the help of electromagnet you can lift up to 20,000 kg of iron. Okay, number two, you remember that it is a use in electrical device such as electric bill. You will see that if you will be open the electrical bill, you will see that there is a magnet. Electrical bill, electrical bill, or headphone. If you will see that the headphone, there will be an electromagnet. Headphone, you see that drum, motor, and there's a different where we can use the electromagnet. Acha, lifting heavy iron scraps, it is used in the electrical device. Acha, it is also used to remove iron particle from any wounds. Okay, I remember that just 1-2 years ago, my one of the friend who was working in a welding industry. So you know that in the welding industry there is a piecing, cutting the piece of iron and all. So one of the piece goes his eye. So he called to me, and we go to the hospital, and the doctor was use a very strong magnet to remove that piece of iron from his eyes. Okay, this is also one use of electromagnet. Okay, so it is also used to remove iron particle from any wounds, and it is also used to remove iron from ores. Okay, it is also used. These are the use of electromagnet. Now see, what is the advantage of electromagnet over permanent magnet? Okay, very important point. What is the advantage? Okay, we already know that what is a permanent magnet. The magnet which is found in the naturally, that is called the permanent magnet. So now the point is advantage of electromagnet over permanent magnet. What is the advantage of electromagnet? So number one, it produces strong magnetic field. Number one point is clear, it produces strong magnetic field. Permanent magnet is also produce a magnetic field, but that is not a very strong. Remember my point. But the electromagnet that produce always a strong magnetic field. Okay. Number one, the polarity of electromagnet we can easily change by changing the direction of current. Remember this point, the polarity of electromagnet we can easily change by changing the direction of current, but the polarity of permanent magnet we cannot change. Okay, for the different purpose there is a need to be change the polarity. So we can change the direction of the current, we can change the direction of polarity of electromagnet, but in the permanent magnet we cannot change its directions. So second point is clear. The third point you just keep in your mind, the strength of magnetic field we can change. Okay, by the changing the number of turns, by the changing of the strength of the current, we can change the strength of the magnetic field of electromagnet. But permanent magnet, once its a magnetic strength will be fixed, so we cannot change. These are the advantage of electromagnet over the permanent magnet. So what are the three important advantage of electromagnet, means why we use electromagnet instead of permanent magnet? So number one, the polarity of the electromagnet we can change by the changing the direction of the current. Number two, we can change the strength of the electromagnet by the changing of the strength of the current, but in the permanent magnet we cannot change the strength of the current. Number three, they produce a very strong magnetic field. Which one? Electromagnet. They produce strong magnetic fields in comparison of permanent magnet. These are the advantage of electromagnet over the permanent magnet. Let's see. Compare of electromagnet and permanent magnet. What is the compare? What is the similarity or dissimilarities? So whatever we learned that, so we can write, we can say that it is made of a soft iron. Which one? Electromagnet is made of a soft iron, and the permanent magnet is made of steel. Number 1 point. Number 2, number 1, it is made up of soft iron. It's made from steel. Number 2, the strength can be changed. Can be changed. Strength cannot change. Strength cannot be changed. Number 3, it can be demagnetized. It can be demagnetized. Magnetized. What is the meaning? It cannot be demagnetized easily. Cannot be demagnetized easily means it can be demagnetized, but it's very difficult. But electromagnet can be easily. Remember that, can be easily demagnetized. Okay, but it cannot be demagnetized. It made from the soft iron, it made from the steel. The strength can be changed, strength cannot be changed. Also right, polarity can be changed. Polarity cannot be changed. Magnetic field can be changed. Okay, write down this. Magnetic field can be changed. Magnetic field cannot be changed. Same point. Okay, magnetic field cannot be changed. So I hope this point is clear. So next video we will discuss few more things regarding the topic. So in next video we will discuss the force of a current carrying conductor in a magnetic field and its application on DC motor. I hope this video is very helpful for you to understand the concept of electromagnetism.